This is the 8th episode of our Chinmaya Algebra series. For this one, we're looking for 1 over xy plus 1 over yz plus 1 over zx, given these expressions for x, y, and z. For this one, we first add the first three equations to come up with something that relates the three variables. We get x minus 1 over x plus y minus 1 over y plus z minus 1 over z is equal to the right side is y plus z plus x. We regroup the left side to get x plus y plus z minus 1 over x plus 1 over y plus 1 over z is equal to rearrange the right side x plus y plus z. Note that x plus y plus z cancels out. So we're basically left with 1 over x plus 1 over y plus 1 over z is equal to 0. Still, that's not the equation we want, but that's something that we can use later on in the solution. So we set that aside for now and look for something to add to this expression. What we'll do is we multiply the equations two at a time, and we do that because it would give us something that has x, y, y, z, and zx in the denominator. Note that if we just add them the way we did in the first part, we do not get the x, y, y, z's, and zx in the denominator. So we do it multiplying two at a time. So for example, if we multiply x minus 1 over x and y minus 1 over y, we get the right side as yz. If we expand this expression, we get xy minus y over x minus uh, x over y plus 1 over xy equals yz. Again, somehow, we ended up with part of the expression we want, that's 1 over xy. We do this for the second and third, and the first and third as well, to get the following equations. Xy minus yx minus x over y plus 1 over xy equals yz. And then if we use the second and third, we get y minus 1 over y times z minus 1 over z equals xz. I'll just box this for later. Expand the left side, we get yz minus z over y minus y over z plus 1 over yz equals xz. This is the second one. The third one would be z minus 1 over z times x minus 1 over x will be equal to xy. So expand again the left side, we get xz minus x over z minus y over z plus 1 over xz is equal to xy. So we get here three equations that if we add, we get xy plus yz plus xz. I'll just combine the terms that look similar in that they have two variables uh, themselves. And then we factor out the negative sign, we get y over x minus or plus x over y plus z over y plus y over z plus x over z plus z over x. And that will be equal to xy plus yz plus xz. I think we're forgetting something here. And what we forgot actually is the expression we want. This ones we forgot 1 over xy and 1 over xc. We add them as well to the left side. That's 1 over xy plus 1 over yz plus 1 over xz. 1 over x y plus 1 over x z. 1 over x y plus 1 over x z. 1 over x y plus 1 over x z plus 1 over x z. 1 over x y plus 1 over x z plus 1 over x z. 1 over x y plus 1 over x z plus 1 over x z. 1 over x y plus 1 over x z 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 plus 1 over x Now note that, similar to the first part, we get some part of the equations that cancels out in the left and right side. So that's xy plus yz plus xz canceling out from the left and right side. Now we already have part of the expression we want. Well, actually, this is the expression we want. We just have to find its value now in relation to this other group of terms. We rearrange this to get 1 over xy plus 1 over yz plus 1 over xz is equal to y over x over y plus z over y plus y over z plus x over z plus z over x. What we can do here is combine the terms that has the same numerator. We get y over x plus y over z plus x over y plus x over z plus z over x plus z over y. If we factor out the y here, we get 1 over x plus 1 over z plus x over x times 1 over y plus 1 over z plus z times 1 over x plus 1 over y. Now going back to what we have earlier, we have established that 1 over x plus 1 over y plus 1 over z is equal to 0. From that, we can rewrite this 1 over x plus 1 over z as negative 1 over y, right? Because if we transpose the other two to the right side, we are left with negative 1 over z, or 1 over y in this case. So we have here y times negative 1 over y plus x times negative 1 over x plus z times negative 1 over z. Simplify that because some terms cancel out. Some common factors or common terms cancel out. The y, the x, and the z, leaving us with just negative 1 for the three terms. Therefore, if we add this, we get negative 3. And since we established this to be equal to 1 over xy plus 1 over yz plus 1 over xz, therefore the expression that we're looking for is equal to negative 3. So this expression here is actually negative 3. And it's our final answer. In my opinion, this is by far the trickiest among the problems that we have published so far. So I hope you learned something from this video, and please subscribe for more content.